Hey, can you hear me? Okay. So thank you, Gorgon, for the intro. And hi, everyone. I'm Ron. I'm leading the research at Bria AI. And I will start this talk from going back 3 years ago to the first time I generated an image from text. And it was back then when I worked at Google and the Imagine model just came out. And I generate this exact image, as you can see right here. And I clearly remember this as a pivotal moment because from this point, I understand that this is no longer just like academia fun. These models are really useful. And ever since, as you all know, these models got better and better. And today we have amazing image generation models. And you can basically create incredibly looking images from just short textual description. So, are we done yet? Is the problem of image generation is solved? And I don't think so. Because these models are capable of more than just generating cool images. I believe that most of the professional visual content will be generated in the very near future. And we're not there yet. At Bria, we work with enterprises, we work with agencies, and we feel their hunger for better visual Gen AI tools for professionals. What we all know, what we all see, is that we have amazing image generation models. But what we don't see is that these models are designed for casual users and not for professional users. And in this talk, I will highlight 2 challenges for using these models for professional use. And the first one will be controllability, because professionals, they need much more control. Just putting a prompt and praying is not enough. And the second one is how we can generate content with copyrights. Because if you're a pro and you want to put your visual on billboards all over the world, obviously you need the copyrights for this, right? And this aligns with the vision of Bria. We build a world where professional creativity and AI innovation coexist. And to do so, we provide visual Gen AI platform for enterprise developers and professional builders. And we are everywhere, trained on licensed data and open source. So we start with the first challenge, controllability for professional use. And we'll try together to understand the problem. Basically, again, we have amazing models for creating images, right? But what happens when a professional user needs to generate content? So here is Yoav. Yoav is our head of creative. And when Yoav generates content, he has a clear vision in his head of what he wants to generate. And Yoav is not going to compromise even on the tiniest details, because Yoav is a pro. But controlling so many image factors like depth of field, color scheme, lighting, composition, expression, controlling all of these, this is so much challenging with current models. So you have struggled to achieve his creative vision. And let's understand why this is happening. This is because the short textual description we use to create the images cannot match the rich details of high-quality image. Image is worth 1,000 words, while today models are trained using 10 words per image. And this results in models that are so difficult to control. And I know that everyone that uses this model feel this feeling, right? Therefore, I'm so excited to present today FIBO. And FIBO is our new image generation model, which, unlike standard models, FIBO is capable of generating an image from 1,000 words. And actually, FIBO is the first open source model that's trained exclusively on long and structured captions. It means that for each training sample, we don't only portray it in details, but we also do it like in a structured way that emphasizes the professional use. For example, I know it's very hard to see, but in each sample, we describe the lighting condition. And here, we describe it as a dim interior. And in this way, we basically train a text-to-image model which map very rich descriptions to rich images. And yes, the model is going to be open source very, very soon. Thank you. And here you can see like how the structured caption is look like. The structured caption is so detailed that it's hard to show it on a slide without a video. And we think this is how a professional control should look like. And now Yoav can create the image which he imagined. And you can see here that using FIBO, you can get much, much closer to your original intention. This is much more similar to the original image. And we can finally control things that were previously much harder to control. For example, here, we change it to deep depth of field. And I know this is difficult to see, especially from the back of the room, but this is exactly how a professional control should look like, the tiniest details in the image. And it actually gets even better. Like, this model was not trained at all for image editing. Like, the model haven't seen even a single pair of images, and yet we see that a native disentanglement emerging just from the structured representation. And this allows us a new interface of iterative refinement. For example, here we can start with the generate image, we can change the text, we can change the season, and we can add raindrop in a very subtle way. And this kind of interface is ideal for professional users. And because the model relies only on the structured caption, which is basically a JSON, there is no drifting even after a lot of iterations. So you basically can iterate it forever and get cool images. And this model also like surprisingly good at breaking out of the data distribution. So you can generate things that were not very common in training, like flowers upside down in a vase. However, can you write a 1,000 words prompt? So obviously not. Even pro users cannot write so much, and therefore we use a VLM basically to complete all necessary details from the user intent. And this actually gives our model much more power, because now our model has more word understanding, reasoning, and it's very easy to integrate with apps which are built with LLMs and agents. And for what we need the V in the VLM, why we need a vision language model. This is because we can also use an image and its inspiration, which is also more similar to how professional users are working. I will skip the technical details, so I'll be on time. And at this point, I know exactly what you're thinking about. You're asking yourself, like, why we need this model when we have Nano Banana, right? And the answer is very simple. Nano Banana is closed. Our model is open. You can fine-tune on your own data. You can create a kind of control that fits your users. You can deploy it anywhere, anyhow, and you can combine it in different pipelines for even like different purposes. You can tune it to create, I don't know, 3D textures or whatever you want. I think it's a very big advantage. So let's talk about like 2 minutes about evaluation. How do you evaluate such models? One way is like automatic evaluations. As you can see here, we use the new Prism benchmark. And indeed, our model outperform all open source models in prompt alignment, which is cool. Another very popular approach is to use the image arena. And for those who are not familiar, this is exactly how the image arena looks like. A user is given a prompt. Here it's a child's first birthday celebrated on the moon, and 2 images, and the user has to choose his preference. So I will ask you, should we have an alien when we generate a child's first birthday celebrated on the moon? Should we? I don't know. Obviously, it depends on the story that we want to tell. And this is a problem today with Image Arena, because basically to win the Image Arena, you need to optimize your model for the average human preference, which it's a very good idea if you're building an app for casual users, and it's a very bad idea if you're building a model for professional users, because professionals want to have that control. They don't want that their model will be fine-tuned through very specific human preference. So we also suggest a new kind of evaluation, which we use basically to train our model. And we call it text as a bottleneck. And here you start with a real image. You turn it to a text. And from this text, you can generate the image using different models. And then you ask the user which image is more similar to the original one. And this measures expressiveness. And the question here is much more objective. It's not about taste. It's about similarity. And obviously, FIBO outperform other models. And I will spare you more graphs and benchmarks, but you can believe me. And when we talk on aesthetics, this is the same thing. We don't want to optimize our model to a specific aesthetics. We want our model, we want our professional user to be able to choose its own preferred aesthetics. And so we will offer different flavors of aesthetics with our model. So this was basically the end of part 1. And now we'll continue to the next challenge, which is data ownership for generative media. And it's an important one. So let me ask you if you ever downloaded music using Napster or Pirate Bay. Do you? Of course you are. And today, are you paying to Spotify to listen to music? Yes, all of you. The only exception is me. It's a little embarrassing, but I'm still using Apple Music. But anyway, this is a very natural transformation. And we suggest here the same transformation. We can just stop scraping data and start paying for the data owners. And Bria is the first company to deploy an attribution model. It means that for each image we generate, we compensate the data owners based on their impacts on generation. And we do this by deconstruct the image to different factors and then calculate basically the cut of each data provider. And this is unlike buying data. This is a very sustainable economic model. We can get endless amount of data without being bankrupt. So it's very nice. And indeed, FIBO was trained on 100% licensed data. So our model is risk-free, which allowing like seamless integration without any worry about such stuff. And again, this is very meaningful when you use the model professionally. And this is why a lot of enterprises, agencies are choosing Bria. And we have done this because we already have a lot of agreements with top data providers like Getty Images, Envato, FreePic, and we have over really top quality, over 1 billion images with top quality. That means that we don't need to compromise on quality even when we train on licensed data. And it brings us to the next natural steps, which is generating premium content with copyrights, right? I think it is inevitable that people will generate like premium content like South Park episodes, and the attribution model basically is the right way to do so. Even the most heavy data scrapers understand that if they want to generate Disney characters, they will have to pay Disney. But again, before we finish, because I'm running out of time, I think the most important part is that in next week, we release a model. It will be open source for non-commercial use. And we also will publish a research paper, and training data will be fully transparent. And of course, our model will be available on FAL, and I want to thank the friends at FAL at helping us creating a new UI that will allow users to experience the structured loan captions. And yeah, we'll also have our own lab. And if you need early access for a model and you want to try it first, you can reach out to me after the talk. So thanks, everyone. Thanks, FAL, for organizing this awesome conference. Thank you.